Hi everybody, so we're going to do another example of using the epsilon delta definition of the limit on a quadratic function. Okay, so again, the first thing I'm going to do is write out the definition. So for every epsilon greater than 0, there exists a delta greater than 0 so that x minus 2, right, x minus a less than delta implies f of x, which in this case is x squared plus 6x minus 1, minus L, which is 15, is less than epsilon. Okay, so we're going to do our first step now and try to pick our delta value. Okay, so we're going to do that. Okay, by starting with what we want to be true, which we know is this, and then we're going to try to force it to be true like we always do. Okay, so we'll start with x squared plus 6x minus 1 minus 15. Okay, and the first thing I'm going to do is combine my like terms. Okay, and then just like the previous example, I'm going to factor this and then see how I can bound my factors. Okay, now this one is fine because we know that this is less than epsilon, or less than delta, I'm sorry. Okay, but the issue is really this one. Okay, so what we're going to do is use that same trick that we used before where we look at this. Okay, and then see what that says about x plus 8. Okay, so again, we're going to let delta be less than 1. Okay, so here we'll say that this is the same as saying x minus 2 is less than 1. Okay, and now we're going to break this up. So this is between 1 and negative 1. Okay, and now again, we're interested in x plus 8, so if I want this to look like x plus 8, I have to add 10 to all three parts. So this is going to give me 9, x plus 8, like I was hoping for, okay, and then 11. So this tells me that the absolute value of x plus 8, okay, is going to be less than 11. Okay, so now if I go back to what I was looking at before, where I had x plus 8 and x minus 2, okay, I can split it up. Okay, and now I can say that this is smaller than 11. Okay, so I'm going to divide both sides by 11. Okay, and here's my value for delta. Delta is epsilon over 11. Okay, so again, we're going to be careful when we start our proof, because when we picked our value for delta, we had two different conditions, right? We were saying that yes, we want it to be epsilon over 11, but we also want it to be less than 1. Okay, so let's go ahead and start our proof. Okay, and we're going to use the same structure as the previous example. So we're going to start by saying let epsilon greater than 0 be given. Okay, and then we're going to say let delta, okay, and then this is again where we have to talk about the minimum, because we want it to be epsilon over 11, but we also want that to be less than 1. So this is the way of saying you're going to choose delta to be the smaller of the two, epsilon over 11 or 1, whichever one of these is smaller, right? That's what this notation means. Okay, so we're going to prove first the thing that we need about 11. Okay, so we're going to start with x minus 2 is less than delta, okay? And then that tells us that the absolute value of x minus 2 is less than 1, since delta is less than or equal to 1, okay? All right, so now we're going to split this up. Okay, and we're going to turn this into x plus 8 by adding 10. Okay, so then we conclude that the absolute value of x plus 8 is less than 11. Okay, so that's not part of our main proof, but we do need to prove this fact in order to use this later on. Okay, so now we're going to start our real proof, okay, and starting with x minus 2 is less than delta, here's where we're going to do our more traditional proof of turning this into f of x minus L. Okay, so in order to do that, we need to multiply, or first we're going to replace this with epsilon over 11. Okay, again, this is true whether epsilon over 11 is bigger than 1 or not. Okay, so this is always less than that. Okay, so now we're going to multiply both sides by x plus 8 because that's what we need to transform this into our original function, right? So I'm going to multiply both sides by the absolute value of x plus 8. Oops, x minus 2. Okay. And I'm going to multiply these two together. Okay, so now I'm going to write out what this is equal to, x squared plus 6x minus 16. Okay, and I'm going to rewrite this in the exact format that's f of x minus L. Okay, so that for this function was f of x was x squared plus 6x minus 1, and then L was 15. Okay. Okay, and then I'm going to use the fact that we proved at the very beginning to say that this is less than 11. Okay, so because this is less than 11, right, this would be smaller than this thing. Okay, and then we're just going to finish and write our conclusion. Okay, so we would write absolute value of x squared plus 6x minus 1 minus 15, okay, is less than epsilon. Okay, so by definition, okay, the limit as x approaches 2 of x squared plus 6x minus 1 equals 15. Okay, so just to review, we used this same trick of saying that delta has to be less than 1 to let us get some type of bound for the other factor, right? Because we already know a way to keep this to be less than delta, okay, which is related to epsilon, but we really have to use this idea of it being less than 1 to tell us something about this other factor, okay? So that's really what we're getting at here, is we need some way to tell us that this absolute value is at least smaller than a whole number that we know. Okay, so we use this trick of saying that this absolute value is less than delta, which is less than 1, to let us put some numerical bounds on this factor. Okay, all right. I am going to do one more example of this that's a special case, and I will see you guys soon.